whatever the universe is made of, therefore, we can think of this as being that perfect fluid. It's just got the energy density and the pressure, and we're going to link the equation of state, which gives me the energy density varying to the pressure. So in other words, we can write that P equals W epsilon, or WE, I'll say rather than say epsilon every time, which is just W rho C squared. And this thing here is called an equation of state parameter. But the fact that the universe is a perfect fluid doesn't mean it's all the same thing. So there are different components that you can think of that make up the universe. So you could think, for example, about radiation, photons. Plenty of photons around. In fact, there's about 10 to the 9 photons per baryon. Although at the moment, most of those photons are from the cosmic microwave background, they carry very little energy, so they don't contribute much energy density, but they're clearly there. And for radiation, W equals 1/3. You have matter. And matter consists of various different things. So you have, stars, dust, gas, etc. This is what you would call baryonic matter. This is the sort of matter that we're familiar with. It's about 4% of the energy density of the universe. And just to put that in context, radiation is currently about 10 to the minus 4 of the energy density of the universe. It was more important in the past, but less important now. And as well as normal matter, of course, we also know, and I'm not going to talk about what it is in this, we have dark matter. There's strong evidence that exists. If it doesn't exist, then in fact GR is wrong, because most of the evidence that comes to us about it is from the form of, it's a form of gravitational experiment. But we don't know what it is. Nature unknown. It's about 23% of the energy density of the universe. And then we have this mysterious thing called dark energy. You'll sometimes see that called the cosmological constant. And I will come on to talk about the cosmological constant later. These things are often used interchangeably. They're not strictly. They're often used interchangeably. And this consists of the remaining 73% of the energy of the universe. It has W less than minus 1/3. And for the cosmological constant, which is often called lambda, W equals minus 1. And the interesting thing you'll notice here is that if P is W epsilon, WE, then that in fact is, not quite sure why it's doing that. Then P equals WE, then P is negative. And we should also have said, of course, for matter, all matter, W equals 0. So these are the components of the universe. I'm not going to go into the observations that show us why they are there, but these are the components of the universe that we will have to think about.